Hi everyone. Today we're going to learn about something called intermolecular forces. So this is not something that we have talked about at all before, but we've talked about something very similar, which is chemical bonds. Remember, if you need to get a hold of me or if you have questions, my email address is rcrawford@jcpsmail.org. Let's jump right in. So I want to start out and I need us to look at two prefixes, and these prefixes are very similar. Remember, prefixes are just parts of words, and these prefixes happen at the beginnings of words. The prefixes that I'm interested in are intra, notice the A at the end, versus inter. Okay? And so I want us to look at some words that have intra and have inter as part of them. Okay? So I want to start out with intramural. Intramural, intramural are usually games that happen inside of a school. Usually, intramural teams are from students within the same school. Now, if we look at, here's a similar word, but it has inter, so intercollegiate. So many of the games that are played between colleges or between schools, we call those intercollegiate games. So intra is games inside or within a school, whereas intercollegiate games are usually between schools. Let's look at another. So intranet, so an intranet is usually like a computer network that's inside of a group or inside of an organization, maybe even inside of a school. But if I look at internet, internet is a network that is between different groups or between different schools or between different people. Okay, so let's look at one more. Intracellular. Now, cellular just means relating to a cell, those basic units of life. So, intracellular means that it's something that happens inside of a cell, whereas intercellular means it happens in between cells, like outside of those cell walls. So, now if we're trying to work out what intra versus inter means, intra, notice how all of these have the word inside. Okay, so intra literally means inside or within, whereas inter, if we compare the two, notice that all of these contain that key bit of between. So inter means between, whereas intra means uh, the inside or within. All right, so let's take a look at that word intermolecular, and then let's see if we can work out what's happening there. So we're looking at two types of forces today. And I want you to know that molecular just means having to do with a molecule. And remember, molecule is just two or more atoms that are joined together. So let's go ahead and put those two prefixes in front of molecular. So intra, meaning inside, intramolecular forces are going to be attractive forces that are inside of a molecule. Okay. If we look, on the other hand, at intermolecular forces, those are going to be attractive forces that are between different molecules. So let's take a look at these two pictures and compare what I mean. So here we have a single water molecule. Hopefully, at this point, you recognize that this is good old H2O. This is water. Okay. Now, when we talked about molecules, we said that these different atoms in a molecule are joined by something we called chemical bonds. Well, really, guys, intramolecular forces, the forces, the attractive forces inside a molecule, those are just chemical bonds, and we're still going to call them that. Chemical bonds, of course, hold atoms together, and these are very strong forces. We've discussed the fact that it is very difficult um, to break apart molecules. I want you to know that intramolecular is not a word I'm going to use. I'm still going to use the word chemical bonds. However, intermolecular forces, this is, I'm sometimes just going to call these IMFs, these attractive forces between different molecules. This is one that I need you to know. So here we have several molecules, because remember, this is between different molecules. And I've got this little static bolt, this little lightning bolt here to represent the IMFs, these intermolecular forces. And so these molecules of water are actually attracted to one another. Okay. Now I need you to know up front, IMFs are much, much weaker than chemical bonds, but intermolecular forces, the things that hold molecules close together, those are something that we're able to see on a daily basis. Whenever we see something has a particular shape or has particular properties, That usually has to do with intermolecular forces. Intermolecular forces are those attractive forces between different molecules. They are not the chemical bonds that hold the molecule together by itself. So, why do we care about these IMFs? Let's uh, let's see what we have here. So first off, intermolecular forces. I need you to know that as molecules get further apart, these intermolecular forces, these IMFs, are going to get much weaker. So here we have these two molecules that are very close together. These molecules are going to have a very strong intermolecular force. But as they get farther apart, as the distance grows, this intermolecular force, this IMF, is going to grow weaker. Now, eventually, we can actually get the molecules so far apart that there is no intermolecular force. It's completely broken down because the molecules are too far apart. So distance matters when we look at these IM forces, these IMFs. It can be really helpful for you guys to imagine these intermolecular forces like tiny springs that are joining these particles together. So they're movable, they can flex, but they're usually not going to break unless we put enough force on it to overcome the IMF. Now, strong intermolecular forces. So some substances are going to have much stronger IMFs than other substances. So, for example, intermolecular substances, I want you to know they're going to determine a lot of the properties. So this is steel. Of course, this is Superman. He's the man of steel. So IMFs are going to determine properties. Remember, properties are just the characteristics of behavior of a substance. So how strong something is, something like steel, its strength, is determined by how strong its intermolecular forces are. So, in other words, steel, it would be very difficult to bend. It's very rigid, very strong. It's going to have very strong IMFs. If we were to look at another substance, so something like a plastic wrap, this is very flexible. You can tear this easily with your hands. Uh, Things like plastics are going to have much weaker IMFs. They're going to have weaker intermolecular forces. Those molecules are not going to hold on to each other quite as strongly as they would in these more durable substances. And so IMFs, thing I need you to remember for today, we are not going to worry about intramolecular forces. We're just going to call those chemical bonds. Remember, these are very strong. These bonds that hold molecules together, these are going to be really hard to break. But intermolecular forces, these are attractive forces that we find in between the molecules that make up something. These are going to be much weaker. And these are between, right? Remember that prefix inter. And I also need you to keep in the back of your mind that this force is going to get weaker as molecules get further apart. And when they get too far apart, the intermolecular force will be completely gone. All right, guys, that's going to do it for today. I hope you have a great day. Take care.